Hello everyone, welcome to today's class, Organic Spectroscopic Analysis. In this lecture, let's learn a new spectrometry technology, which is mass spectrometry. First of all, what is mass spectrometry? Mass spectrometry consists basically of weighting ions in the gas phase. The instrument used could be considered as sophisticated balance, which determines with high precision the masses of individual atoms and molecules. Let's hear what Jonathan said. He was the 2002 Nobel Prize winner in chemistry for the originator of electrospray ionization from biomolecules.
The mass spectrometer, in a very real sense, can be considered as just the latest development of this gravimetric balance. And its big advantage is that it is able to determine the mass to weigh individual atoms and molecules, which, when you stop to think about it, is quite a feat because these individual atoms and molecules are really very small.
He said, mass spectrometry is the art of measuring atoms and molecules to determine their molecular weights. Such mass weight information is sometimes sufficient, frequently necessary, and always useful in determining the identity of a species. As we all know about the Manhattan Project during the Second World War, invented atomic bombs. The most critical material in nuclear bomb is uranium-235, an isotope of uranium-238. People used a mass spectrometer to separate uranium-235 from uranium-238. The Manhattan Project designed a mass spectrometer with a magnetic sector to separate uranium-235 from uranium-238. The two isotopes were ionized in the ion source and separated with the magnetic sector as two ejector rays, arriving at different collectors. In 1886, E. Goldstein discovered anode rays, positive gas ions, in gas discharge. In 1897, J.J. Thomson, the British scientist, discovered the electron and determined its mass-charge ratio, and produced the first commercial mass spectrometer in 1912. In this picture, cathode rays was deflected by a magnetic field. J.J. Thomson won the Nobel Prize in 1906. In 1898, W. Weil analyzed the anode rays by magnetic deflection and establishes that they carry a positive charge. He won the Nobel Prize in 1911. In 1909, R. A. Wilkin and Fletcher determined the elementary unit of charge. Francis William Aston won the Nobel Prize in chemistry in 1922 for his discovery by means of his mass spectrograph of isotopes. In a large number of non-radioactive elements, and for his enunciation of the whole number rule. In 1953, Kochel and Eintracht mass spectrometer was produced. Wolfgang Paul won the Nobel Prize in physics in 1989. In 1956, the first GC mass spectrometer was produced. In 1968, the first commercial Kochel MS was produced. In 1975, the first commercial GC-MS was produced. In the 1990s, there was an explosion growth in biological MS due to the electrospray and matrix-assisted laser desorption ionization techniques. In 2002, John Finn and George Kanata shared the Nobel Prize in Chemistry for their development of soft desorption ionization methods for mass spectrometric analysis of biological micromolecules. The basis of mass spectrometry is as follows. 1. A mass spectrometer determines the mass of a molecule by measuring the mass-to-charge ratio of this ion. Ions are generated by introducing either the loss or gain a charge from a neutral species. Once formed, ions are electrostatically directed into a mass analyzer where they are separated according to mass-charge ratio and finally detected. The result of molecular ionization, ion separation, and ion detection is a mass spectrum that can provide molecular mass and even structure information. Over the past decade, mass spectrometry has undergone tremendous technological improvements, allowing for its application to proteins, peptides, carbohydrates, DNA, drugs, and many other biological relevant molecules. Due to ionization sources, such as electrospray ionization and matrix-assisted laser desorption ionization, mass spectrometry has become a replaceable tool in the biomolecular science. What's the characteristic of mass spectrometry? Firstly, high sensitivity and low sample consumption. It's the method of choice for the analysis of trace materials as pesticide residues and drugs and their metabolites, especially in forensic and medical research. It's important for bringing cheating athletes to heel. Fast, intuitive, wide applicability and wide application range. It can be effectively combined with a variety of chromatographic techniques such as GC mass, LC mass, CE mass, tandem mass, etc. Among the 4 important means, which are NMR, MS, infrared, UV, of identifying organic compounds, mass spectrometry is the only way to determine the molecular formula. In the numerous applications of mass spectrometry, frequently the single most important requirement is to obtain a molecular weight. That's today's lesson. Thank you for watching.